Hello lovely people, in this video we will be checking out this ATOTO S8 MS distortion measurements. If you watched my previous video, you saw that I did kind of an unboxing video for this head unit, which was sent to me by ATOTO for a review. And in my channel, I don't read the manufacturer's description on the webpage. I don't say pretty things. I take stuff apart, see what's inside, and provide you with actual factual data and objective measurements of how the item performs. So in this video, we're going to do exactly that. Just a reminder, this is a 7-inch Android head unit that has only high-level outputs of the amplifier. It doesn't have RCAs, it doesn't have any digital output, nothing. And how you're supposed to use, if you want to connect the amplifier, you're supposed to use this high-level to low-level adapter. Now, in this video, we're going to do a few different things. So first of all, we're going to go through all the measurements, distortion measurements of this inbuilt amplifier. I'm going to take it apart. I'm going to show you the chip. And then if you're going to stick till the end, I'm going to tell you what is the best way to use it with an amplifier and what kind of amplifier would be best to use with a head unit. Because as I mentioned, as RCAs, it has only high-level outputs. And then in the very end, I'm going to give my personal opinion about is this head unit worth to have it for specifically SQ purposes, or it has some kind of other purpose, and we're going to try to discuss that. So even if this video is about this specific model, SHD2, whatever the number, the conclusions of this video is going to summarize the vast majority of Android head units and probably vast majority of other head units because they are built kinda in the same way. And if we're talking about built-in amplifier, it is a chip that is inside, and we're going to take it apart. We're going to have a look what kind of chip it is. So take it apart. It's just a few screws, so let me undo them. Okay, so we're going to take it apart, and you can see inside we have some jumper cables that go from the main board, motherboard, to the screen. And here basically you see what you're paying for when you're buying an Android head unit. You're paying for the screen and you're paying for basically this, whatever this is. So what is this? Let's unscrew another 4 screws and look a bit deeper. Okay, so if I'm going to be very careful, I'm going to try to remove this board from everything else, just like that. I'm going to flip it, and here you have the heatsink, which is just aluminum piece of heatsink. And here you have a little slot where you see this thermal paste. So this is where the actual chip, the amplified chip, goes in. And here is the main board. So all of this area on the left side is your like processor, memory, and all the Android stuff that you have in a typical tablet. And on here, we have a capacitor that's supposed to supply the amplifier with some extra current when it needs it, because the power is right there. And this is the actual amplifier chip. So this chip is TDA7388. And this is exactly what I mean when I said that this is gonna apply to most head units, even if it's not Android, because the TDA chips are being put in most head units. It could be a slightly different model, but these TDA chips, you can buy them for probably a few bucks from AliExpress. These look like genuine TDA chips, and what they are is they are AB class 4-channel amplifier. Now, probably when you see this board, even if you're not familiar with any kind of circuit boards or anything, you probably can tell that there's no power supply or anything, because these chips run over 12 volts or 13 or 14, whatever comes from your battery. So they cannot have a high rail voltage and they cannot supply a lot of power. And if you see on the box written 4 times 50, you can say 100% that it will never do 50 watts per channel because of 12 volt rail. So now, since we know what is in the actual head unit, what kind of amplifier it is, what we're going to do, we're going to pull a data sheet for this specific chip. We're going to have a look at that chip, and then I'm going to put this on my measurement system, and we're going to measure the THD and everything else. If you want more in-depth information of how I do my measurements, what kind of measurements I do, and how to understand those measurements, I have a separate videos for that, so I'm going to link them in the video description down below. But for this specific purpose, I'm going to try to scale down the technical stuff and make it more understandable to literally everyone. So let's jump into the laptop and let's have a look at the data. So in all this measurement set, we do have quite a few different measurements. First, and probably the most important measurement of any amplifier is total harmonic distortion compared with the output power. This is a typical curve that we call THD versus level, and that means that this at the bottom axis is our level in watts. So this is 1 watt, 2 watts, 3 watts. Basically, the more you turn the volume up, the more you go on this line. And the y-axis is the distortion in percentage. So everybody knows that clipping starts like 1% and all the power is measured up to 1% clipping. So we can see from this line that 1% clipping is somewhere here. And according to the graph, we have about 16 watts of power until 1% of clipping. So we can say that this head unit, all of this was measured on 13.2 volts lithium battery. So this head unit has about 16 watts per channel. Now, is this a lot or is this very little? For a head unit, this is exactly what you're gonna get with any kind of head unit, because most of them, as I mentioned, they use the battery voltage as a rail and they cannot produce more power. It doesn't matter what kind of chip they're using. So all head units are gonna have 12, 13, 15 watts of clean power up until clipping. Now here at the bottom we see that the lowest point that we can see is somewhere here. The THD plus noise with this, which is total harmonic distortion plus noise, is 0.03%. Basically, the only thing you need to understand with all of these measurements, distortion, it's either percentage, either dB that I'm going to show you in the other graphs. The lower everything is, the better it is, and the higher everything is, the worse it is. So this THD line, if it would be like here at 0.5%, that would be really, really bad. If this line would be very, very low, like somewhere here, it would be super, super good and very clean. Now, this distortion, if we're talking 0.03%, is it a lot or is it not? So in my testing, I drew imaginary lines through 1%, 0.1, and 0.01. So 1% is our clipping point. 0.1, to me personally, in my testing, is the line that differentiates bad amplifiers from kinda okay and good-ish. So everything that is above 0.1, I would consider that bad. Everything that is below 0.1 is good. And the other line, 0.01, if an amplifier measures lower than that, if it has less distortion than 0.01, I call it a super good, super excellent, or super clean amplifier, and everything above is kind of okay and normal. So you can see this amplifier sits right between those two imaginary lines that I kind of draw, and I would consider this to be a average quality, kind of goodish, not bad amplifier. The only downside to this obviously is going to be the power output. Now, for reference, just for you to see how a good amplifier measures and looks. For reference, I have my Alpine F409 amplifier, which is probably the cleanest amplifier that I have, one of the cleanest amplifiers that I have. And it looks something like this. So this is the total harmonic distortion versus level of this head unit, which is in red, and my amplifier, which is in yellow. And you can see that this amplifier, it measures super clean. You remember this imaginary line is 0.01? This amplifier is always below that line, and it goes down all the way to 0.02%, which is super mega clean. And it gives about 73 watts, 74 watts of super clean power per channel. And this amplifier, the head unit, which is expected, performs like that. So from this measurement that I did, we can see that it goes down to 0.03. Now let's have a look at the data sheet. This is the data sheet for this TDA7388, which is exactly the same chip that we have in the head unit. And if we're going to scroll down and we're going to zoom in slightly, we're going to have a look at this graph, which is exactly the same THD versus power. And this is tested at 1 kilohertz, exactly like me. And you can see 0.01 is 0.02, so it sits at about 0.02%, and our amplifier sits at 0.03, so it matches very nice with our measurements. And you can see here it goes to like 15, it's here 16-17 watts, and then it goes up to clipping, and we measured exactly the same, 16-17 watts, and then it goes into clipping. So we can say that this chip was implemented very good, because that one measures slightly better in ideal conditions with like minimal circuitry and anything, but this is inside the head unit. So we are losing some THD, but it measures very nice according to the specs. Now what's gonna happen if we're gonna connect the high to low level converter? Obviously things are not going to improve, and they are slightly worse. So let me adjust the graph and shift this to volts, because the RCA output is not in watts but in volts. So how much can we expect from the RCAs, because it is claimed that it's 2 volts, and at 1% we're actually getting very close to 2 volts up till clipping, but it starts to clip here, which is 1.8 volts. So we can say that from the RCAs using the high to low level converters, we are getting about 1.8 volts of clean power. Now that clean is, you can see this is 0.1 line. So this is the line where I said for me personally differentiates bad from kinda good. These converters, they do reduce the sound quality, and quite a lot. Now these spikes that you can see here, just ignore them, because this is just the level converters don't like to be measured for some reason, probably because of the quality. But if you're planning to connect this head unit to an amplifier, please do not use these converters and just use the actual head unit out on high levels, because it is much cleaner than that. I can show you right here as well on this graph. This is the LOC. I'm going to remove this good amplifier, and you can see that, just disregard the watts and volts, just look at the overall level, and you can see that the LOCs are quite much more dirtier compared even with the high level outputs. Now, when I measure this amplifier, I could only test it 3 ways, so which is auxiliary inputs, which is the analog inputs. Then I could test via USB, so I can put some files on the USB, and I can test the Bluetooth. This graph, the level that I showed you, I can only test it on analog inputs. I cannot test it on any other one. So this is kind of summarizes how it performs. The other thing that we're going to check is THD dependency on frequency, because the harmonic distortion is not the same on all frequencies. So if we have a look at auxiliary input, so this is analog input depending on frequency. And what we want to see, this line obviously to be as low as possible and as straight as possible. It is common to have for amplifiers rising THD depending on frequency. So for higher frequencies, you have more distortion. Ignore these little wiggles. I'm not sure why they are there, but if you can imagine a straight line, it would be just a straight line. So we can see that this is something about kind of the same, 0.3%, and it's all the way, and then it rises up to 0.3. which is quite a lot. For reference, this is the measurement of my Alpine amplifier, which is this. And you can see this, it's super low. So it starts at 0.001 and then it rises slightly up till 0.015. So this is, for reference, is a super clean amplifier. Obviously, this head unit is not as clean, but that's expected. So this is using the analog inputs. This is if you're using the USB. So USB and analog are kind of the same, very similar. We can say that USB measures slightly better than auxiliary inputs. And to be honest, it should be that way. So if you're using a head unit, everything from the USB should be the cleanest. Now, let me show you what happens when you're going to try to measure with a Bluetooth. Something like this. So all the higher frequencies and middle frequencies are kind of okay, down to 200 Hertz, and all the lower frequencies, you have much more distortion. Well, much more, 0.1. So it's not that bad, and for low frequencies, it's not as noticeable, but there is increase in distortion on lower frequencies. However, what happens if we're going to connect the high to low level converters? It's something like this. And let me remove this one just for clarity. And you can see that using high to low level converters, we have a massive rising distortion if we go to the lower frequencies. And like at 100 Hertz, we already have 1%. Slightly lower, sub bass, like 40 Hertz, it's 5% distortion only by using the high to low level converter. So again, just a cautionary thing, do not use those converters if you care about sound quality at all. The best way is to use high level outputs and connect them directly to the amplifier. Now, this graph is a snapshot of a 1 kilohertz tone playing at 5 watts of output. So this is a typical for measurement for all the amplifiers. And what we're looking for on this measurement is to have this, which we call a noise floor, to be as low as possible. And these are the harmonics. So this is the 1 kilohertz tone that is playing, and all of these little lines are harmonics of the fundamental note. So this is 1 kilohertz, 2 kilohertz, 3 kilohertz, 4, 5, 6, and so on and so on and so on. What you want to see with this measurement is these harmonics to be as low as possible and to have as little harmonics as possible. So if you have, for example, an amplifier that has only 2 of these harmonics and they are like below 90 dB, which is this one, that's going to be an excellent amplifier. This amplifier, you can see most of the harmonics are like minus 85 dB. And it's a lot of them. It's like loads and loads of them. These tallest ones, which is the second and the third one, is minus 72. People that are more experienced than me, they will say that if you have a harmonic of about minus 60 dB, which is this line, that's going to be clearly audible and is going to influence the sound and is going to color the sound. Harmonics at 80 decibels or below, it's kind of debatable. They might be audible under certain circumstances, and everything at 100 Hertz and below, it's clearly not audible at all. So you can see this being about 72, it's kind of might be audible or maybe not. For comparison, this is a snapshot of my Alpine F409. You can see the noise, it is much lower. And if you have a look at the harmonics, I'm going to remove all of these. You can see harmonics that you have. The highest one is this one, which is minus 95 dB. And all the other ones, apart from this one, are kind of minus 100 dB and lower than that. So this amplifier has quite a few harmonics, but they're super low in level and clearly not audible. Now let's compare these different inputs of this head unit. So this is auxiliary, this is USB. So USB and auxiliary is very similar. There's barely any difference. Auxiliary has some other weird harmonics, like this harmonic, this, some extra, but the level of other harmonics are kind of the same. So we can say that USB and auxiliary are kind of the same. Now watch what happens when I'm going to show you the Bluetooth. this is the Bluetooth. And this is probably the worst measurement that I ever saw. And why is that? Because the Bluetooth chip in this head unit, and again, I'm going to generalize that most head units, doesn't matter really the price, unless they have like aptX HD or higher support, most head units are going to have the cheapest, worst performing Bluetooth chips ever. And this is exactly what you have within this case. This is a chip that runs at 44.1K, 16 bits, and it's an SBC codec. So that codec supports up to 320 kilobits per second, which is fine for Spotify streaming or like MP3s. But anything higher than that, yeah. And you can see that this looks nothing like it should look. The noise is horrible, the harmonics are horrible, and even the fundamental note, you see, supposed to be one spike, you see in this one, but it's like a mountain, so it's really, really bad. Now, the LOC looks very nice. Why is that? Because if we're gonna go back to the distortion of the LOC, this is at 1 kilohertz. So at 1 kilohertz, it's not that bad, because we can see the same here, that at 1 kilohertz is 0.1. It's not that bad. The LOC performs worst at lower frequencies. So this, the spectral, it's not that bad. However, the harmonics are much higher. So like the third one, it's all the way up to -60, which some would say is going to sound very harsh and unpleasant, because odd order harmonics to our hearing sound very bad. So again, LOC is very, very bad. Next thing that we're going to have a look at is intermodulation distortion. Intermodulation is when you play two tones at the same time and you're looking at the harmonics. So for example, this specific one is a 60 hertz tone and a 7 kilohertz tone playing at the same time. And here at 60, you can see all of these harmonics, and the principle is exactly the same. You remember, 60 audible, 80 kind of debatable, everything below 100 is not audible. So for lower frequencies, we have quite a few harmonics and they are quite high. So this is on auxiliary input. And for higher frequencies as well, we have a little mountain of spikes and harmonics around the 7 kilohertz tone, and something happening here as well, which is 14 kilohertz, which is the second harmonic of 7. So it's not that great. For reference, again, I'm going to show you the Alpine F49. It looks like that. So let me remove this. You can see that this, all these spikes are below 93 dB, and this harmonic is below 100, and all of this is minus 110 decibels, so it's clearly not audible. This is an excellent measurement of intermodulation distortion. This head unit, it has some problems. If we're going to compare this to USB, kind of the same. The USB is slightly cleaner. You can see that harmonics are slightly lower. We don't see this one. And if we're going to compare, yeah, USB is slightly cleaner as expected. And if we're going to have a look at the Bluetooth, it's a disaster. It's a literal disaster. Look. So this is how it should look like. And this is how it looks like. All of this is just horrible harmonics and distortion and noise. This is really bad. Like the Bluetooth on this thing is really bad. And again, it might sound harsh that I'm saying this, but this is very typical of any head unit with these kind of JL type generic Bluetooth chips. It's really bad. Intermodulation distortion on the high to low level converter, it's horrible. It's as bad as Bluetooth, but it just has much more harmonics. If you compare the USB with the low level converter, you can see this, the third harmonic on the converter is at minus 30 dB. That is clearly gonna sound not nice at all at lower frequencies. So yeah, and loads, you can see all this little forest is going there. That's horrible for lower frequencies. The other measurement is exactly the same intermodulation distortion, just on higher frequencies. So this tests the amplifier's ability to reproduce the high, very, very high frequencies. So these are two test tones at 18 kilohertz and 20 kilohertz, and we're looking for all of these harmonics and 2 kilohertz harmonic as well. So these surrounding them, you can see it's minus 53, so that if we're not going to hear that high, but the same test can be performed at lower frequencies like 10K, 12K, which we can hear clearly, and these harmonics at minus 53 is going to be audible. Again, for reference, I'm going to show you the Alpine, which looks like this. Let me just remove it. You can see these harmonics. So this one spike at higher frequencies at 38K. This is a power supply switching frequency, so this is not important. We're looking at these, the ones that are next to these big spikes, and you can see these are minus 80 dB, and the other ones are lower. So this is not great, but this is good. However, the head unit, you can see the harmonics are much higher. Let's have a look at the USB compared to the auxiliary. USB again performs slightly better. Now let's have a look at the Bluetooth again. Bluetooth is, oh my God, what's happening? So what's happening is, I will talk about this a bit later, the fact is that Bluetooth, this specific Bluetooth chip, doesn't play anything above 16 kilohertz. That's why we don't have a measurement for this 18 and 20K, because the Bluetooth just doesn't play that. I'm gonna show you that later. And if we use the LOC again, it's not as bad at higher frequencies. The LOC is very bad at low frequencies. At higher frequencies, it's not as bad, it's minus 71. And one of the last measurements is the multi-tone distortion. So multi-tone is a one tone that is comprised out of 30 different tones. And you can see these tones are like here, 1, 2, 3, 4, and all these like peaks is a separate tone. So it sounds like an organ something music when you play it all by itself. And what we're looking for this one is to have very clear fundamental notes. We don't want to see any noise like this, and we ideally would want to see it flat. So for example, again, my Alpine measures like this. You can see it's all flat. You can see all the tones and just slightly a bit more noise and the higher frequencies this amplifier. However, this head unit, we can see it's, yeah, so it's not as bad at higher frequencies. It's getting worse and lower frequencies. So basically this means that the chip, the amplifier, cannot reproduce all frequencies equally the same, and it kind of struggles with the lower frequencies. If we're gonna have a look at the auxiliary input, it's much worse, because the noise and everything goes up and we're losing the dynamic range. Dynamic range is basically when you're playing music and how accurately the amplifier can reproduce very low volume sounds compared to very high volume sounds. So again, if you compare this to a quality amplifier, you can see there is a big, massive difference. Now let's have a look at the Bluetooth. It's horrible. Even if you compare it, Bluetooth with USB, the Bluetooth is really bad. It's so much noise, and probably because of the bandwidth or something, I don't know, it's just, it cannot play music properly. The high level converter, it's even worse than Bluetooth. You can see at lower frequencies, there's literally nothing. And again, this is how it's supposed to be. Now, one last thing before we jump into the subwoofer output, we're gonna have a look at the frequency response. Okay, so this is the frequency response of my Alpine amplifier. So this is a very zoomed in graph. So we can see this is one grid line is 1 decibel difference. And this amplifier, if we have a look at 20 to 20, which we usually look at, 20 hertz to 20 kilohertz, it's absolutely and totally flat. There is literally 0.1 or 0.2 dB difference, but it's totally and absolutely flat. If we zoom out to the frequency range, we can see that it plays down to whatever, and at 10 hertz, it's barely half a dB down, and the same at 40 kilohertz, we have same 0.3 dB down. So it's a super linear amplifier. Now this is a reference. Let's have a look how this head unit performs. This is the auxiliary input. So auxiliary, it plays up to 20k and then it drops down. So again, it's limited to 48 kilohertz, the whole head unit. And it kind of started to roll off at 400 hertz and then goes down, half a dB down at 100 hertz and 1 full dB down at 20 hertz. It's not a big of an issue, but just to note, it's not as linear. Now USB is something like this. So this is what I noticed, that if you compare, let me remove this Alpine. If we compare the auxiliary with the USB or Bluetooth, the crossovers that are in the head unit, they apply only for the USB. They don't apply for the auxiliary inputs, which is very weird. And for this, we have frequency response that is kind of dropping off at the top end. So we have half a dB down at 20 kilohertz, and we have a rising bottom end for some reason. At a 20 hertz, we have plus 1 dB and half a dB. You're not going to hear that, but again, it's just to know that the frequency response is not linear. Now, what happens with Bluetooth? Bluetooth is like this. It's like, what the hell is this? So we can see the bottom end is kind of the same as with a USB. However, we have this weird bump at 1 kilohertz of 1.5 dB. I don't know why, because I did check all the EQ settings. Everything is flat because EQ should be applied to all the inputs. So there's nothing there, but for some reason on Bluetooth, it has this little peak. I don't know why. And the best thing about Bluetooth, as I mentioned, at 16.8 kilohertz, everything drops off a cliff. So it plays up to like 17k or something, and then nothing. Granted, most people are not going to hear that. I can hear only up to 16 kilohertz and no higher than that. But again, if we're looking at just objective measurements, this is how a typical cheap Bluetooth chip performs. And the last one is the high to low level converter. Plays all the way up to 20k, a slight drop. But again, for some reason, it just drops level at a 20 hertz. We have -4 decibels, which is very weird. It's even more bigger drop than compared to the auxiliary inputs. So this high to low level adapter, it acts almost as a high pass filter. But again, for this measurement, there was no high pass filter applied in the head unit. It's just a high to low level converter. So yeah, it's not great at all. And again, just for reference, just for you to show, this is how it should be. It should be totally and absolutely flat. And finally, we came to the RCA out for the subwoofer. So in the manual, it is stated that it can do 0.8 volts of output. However, I did measure it, and it measures nice and clean up to 1.6 volts, which is kind of double what the manual states. The only thing you need to do in the subwoofer submenu, you have to raise the level to +10, and then it gives you more output. It's not clipped. You can see 1.6 volts out. You have 0.06% of THD, which is below 0.1 for a subwoofer output. It's amazing. It's a very clean output via RCA. So I would imagine if this head unit would have RCAs, we could expect a similar performance. Now, granted, this test was done on 50 hertz node, not 1 kilohertz, because subwoofers are tested slightly differently. But we have much more than 1 volt out clean of the RCAs. This is the same kind of one sine tone It's just for the amplifier outputs we were using 1 kilohertz tone, but the subwoofer output we're using 50 hertz tone. So we can see that's a one tone and everything looks nice. It's just a few little harmonics. They're all the way down, which is very nice to see. So the RCA output is very clean. However, if you use Bluetooth, you have this. So again, Bluetooth is a horrible output. It doesn't matter the frequency, especially for the lower end, it's very bad. And the last one, just for you to show, is the subwoofer frequency response. So this head unit, as I mentioned, it has kind of a built-in high-pass filter at 20 hertz, unless you're using auxiliary inputs. But yeah, it's that. And this crossover, I think it was 250 hertz, the maximum that we could. Yeah, it does go down. However, you can see it's flat. It's very nice. So the RCA output of the subwoofer, it's nice, as long as you don't use the Bluetooth. So there you have it, all of the distortion measurements of this little head unit. If I would summarize it, is it bad or is it good? It is as I expected. Nothing special because it is a chip amplifier, but not as bad as I expected as well. So as long as you don't use the built-in Bluetooth, you're gonna be fine. The best way to use this head unit is to have all your music on a USB stick, on a hard drive or something, and play it via built-in player. If you want to connect the amplifier, use the high-level outputs. Do not use these little things. When you receive them, bin them straight away because it's horrible. Most amplifiers these days come with high-level inputs, so you can use these. If you want to use this head unit with a DSP, just bear in mind that this head unit, as most head units, is going to be your bottleneck. So how to choose a good amplifier for this head unit? When you saw the distortion measurement, the main thing that we were looking at is THD versus level. And you saw that the distortion, the lowest, was 0.03%. This number is not bad. However, this is the level of distortion that you have from budget and SPL type amplifiers such as Taramps, D4S, JP amplifiers, maybe SCAR, and Zapco. Now, yes, you might think, really? Zapco? Yes, from what I saw, Zapco amplifiers objectively, measurement-wise, have the same level of distortion as this Android head unit. Granted, they have much more power, but cleanliness-wise, it's kind of the same. If you have this head unit or similar one or any kind of Android head unit, don't spend a lot of money on amplifiers if you want to keep this head unit, because you're not going to gain anything by connecting a very quality SQ amplifier from reputable brands like JL, Alpine. Even Kicker amplifiers are probably cleaner than this, so don't waste money there. And if you want something better than this, look out for the one with the digital output, or at least with some RCAs. So we kind of came to the conclusion that this head unit is really not for SQ. So what is it for? This head unit is a perfect option for a person that wants connectivity, wants options, and wants to have something that can be used without a phone, because this has many options. You can insert a SIM card, you can connect to Wi-Fi, and it can do everything that your phone can do. So if you want to watch YouTube videos while you're waiting for something, if you want to stream music, if you want to browse or do something else on the net, and don't worry about Wi-Fi because it does have a SIM card, this unit, it's perfect for you. But if you're aiming for ultimate sound quality and you want the best possible sound, if you want very good tuning capabilities, and this channel is kind of about that, this head unit is not for you. And I guess this is the whole point of any kind of product, that every product is designed for a specific purpose. And sometimes you just have to find that purpose. So by doing these tests, by measuring distortion and everything, we found the perfect use case scenario for this specific head unit. and not only the specific head unit, but probably most of them. So I hope that this video was informative and you learned something new. If you did, give me a thumbs up. The next video is going to be all about tuning. We're going to try to install this in my car, and we're going to try to tune a system according to typical SQ principles, and it all going to depend on the tuning capabilities of this unit. So thank you very much for watching, guys, and I will see you in the next one.